All right, class, welcome back. This is 2.5, and we're going to be talking about compound inequalities. So I left kind of all the information about inequalities that we talked about in 2.4, which you can go back and watch that video if you need to. Again, real quick reminder, if you have greater than or less than, then you're going to use a parenthesis, and if you have greater than equal to or less than equal to, then you are going to use brackets. That means that the value is included, and a parenthesis means it's not. Infinity always has a bracket, and if you multiply or divide by a negative, you have to flip the sign. Okay, and then these are our steps for solving. So what we want to start out with is, what is a compound inequality? A compound inequality is an inequality that uses the words and or. Okay, so this is a compound inequality, and this is a compound inequality. When we're talking about inequalities, we've got intersections. Intersections use the word and unions use the word or. Okay, so an intersection means that if you have a set of something, say set A, and another set B, and is this section right here. So this intersection means all the elements that are in common. So all common elements. Elements are just any part of the solution. So like 2 could be an element, 5 could be an element, positive numbers, negative numbers, even numbers, odd numbers, whatever the case is. Okay, so these are all the common elements in both sets. Okay, an intersection, the symbol for it is an upside down U. Okay, and again, you use intersection when you have an and statement. Okay, and we're talking about these values where they share, or the overlap in both sets. Union means or. So if you're looking at set A or set B, you're looking at everything that's in either A or B. So it's whatever's in both, it's all of them. Okay, so this is all of the elements that belong to either set. Okay, all elements that belong to either set. So that, again, union is the word or, and we represent this with a U. So this would be anything that's in set B and anything that's in set A, all of that would be included in our union. Okay, so this here, this compound inequality is an intersection, and this one would be a union. All right, so this is kind of all the background information on inequalities. Okay, so let's do a set, which we have there on our guided notes. So if we had these sets, let's see on these guided notes. So set A is comprised of -1, 0, 2, 3, 7, and 11. Those are all of the elements in set A. In set B, we have -5 and 7. And in set C, we have x is such that x is an even integer. All right, so we've got 3 sets, set A, B, and C. Now we want to find, first thing we want to find is A intersection B. So where does A intersect B, or what do they have in common? Well, in this case, the only thing they have in common is this 7. It's an element that's in both. So this would be 7. Okay, the intersection of A and B. So if we took all of the stuff in A and put it in one circle, and all the stuff in B and put it in another circle, they would both have a 7. Okay, the next one we want to find is the union of A and B. The union is any of the elements that they share. So the union would be any elements in either set. So -1, actually let's start with -5, it's the smallest number. By the way, you list these from smallest to largest on the number line. 1, -1, 0, 2, 3, 7, and 11. Again, the union means all of the elements in either set. The intersection means only the common elements between the two sets. Okay, the third thing we want to find here is B intersect C. And our B intersect C is what they have in common. Now you'll see -5 is odd and 7 is odd, and X in C is an even integer. So we're saying, well, what is in both of these sets? What do they have in common? And you can see here that they have nothing in common. So this solution would be called the empty set. The empty set. Okay, so the empty set just means that there is no solution. They share nothing in common. So now I want to do a B, set B union with C, and this is going to be everything that is in one set or the other. So the way that we would write this is we would say X is such that X is an even integer, and, well, this one is an or actually, or X is -5, or X is 7. So this is the solution set to those examples on your guided notes. Okay, next we're going to do a couple of compound inequalities and graph the solution set in interval notation. So we're going to be using all of this information to do that. So here we go. First problem we want to do, let's start with an and. So we want to know the compound inequality X is less than 2 and X is greater than 4. Okay, so if I were to draw a number line, got 0, 1, 2, 3, 4, so 2 and 4. This inequality says that X is all of the things facing this way. Anything less than 2 and not including it. Okay, this inequality says that X is all the things greater than 4, so everything facing this way but not including it. So remember that this word and means what they have in common. So as I'm looking at this graph, you can see that they don't overlap anywhere. And because they don't overlap anywhere, then the solution here is actually the empty set, which means you would just have a number line. So remember, I'm graphing both of these, and the thing I'm graphing is what would make both of these statements true. Well, there's no number that I could plug in. Like if I plug in 0, this statement's true, but that one's false. If I plug in 5, this statement's true, but that one's false. If I plug in 3, they're both false. So there's nowhere, no number that I could plug in to both of these and make it true. So my graph would be this, the empty set would be my solution, okay? So let's try another one. All right, so we have -7x is less than or equal to -21, and x minus 20 is less than or equal to -15. Remember that and isn't just where this one is true or this one is true, it's where they're both true. So we're looking for what overlaps, what they have in common. Okay, so first I need to solve both of these inequalities. I'm going to solve this one by dividing by a -7, and because I'm dividing by a negative, got to flip that sign. So I end up getting the x is greater than or equal to 3. Here I've got to add 20 to both sides. So here I get that x is less than or equal to a positive 5. So if I were going to graph these, I've got 3 here and 5 here, and I'm going to graph these in green and blue. Okay, so where x is greater than or equal to 3, so it includes 3, but it's all of these values facing this way to positive infinity. But this one says x is all the values that are less than or equal to 5, so it includes 5, but is going this way. So you can see here that the area that overlaps is this right here. So my graph for the solution would look like this. It would only include where they overlap. And if I were to graph that or write that in interval notation, then I would say that this is 3 including it because of the equal to sign right here, and 5 to 5 also including it. Okay, so again, my graph solution and my interval notation. This is just to show you where they overlap and kind of figure out what the solution is. Here's what the solution would look like. All right, so let's do another one. This time we'll do an OR. So if we have 3x minus 1 is less than 12, or x plus 7 is greater than or equal to 10. So my first thing here is I got to solve each of these inequalities. This one can be simplified on this side here. So I'm going to get 3x minus 3, and that's going to be less than 12. Still can work with this one, so I'm going to get the 3 away from it by isolating the variable here in step 2. Then I am going to divide by 3 to get the coefficient to be 1, and I didn't divide by a negative, so I'm going to keep that sign. So x, the solution to this one is x is anything that is less than 5. Now this one I'm just going to subtract 7 and get that x is greater than or equal to a 3. All right, so what would this look like on a number line? All right, so this one says that 5 is anything that is less, or x is anything that is less than 5. So this is going this way, and it doesn't include 5 here. And this one though, this one says x is greater than or equal to 3. So it's going this direction towards the positive infinity. Okay, so how is this one different from the last one? Well, before we were only talking about where they overlap, but now that we're working with the OR says, well, what's true for one is fine. It's an either. What makes either true? Remember, this means either true. Well, if that's the case, then every number on this number line makes either true. So the graphical solution then would look like this. And it would be all of the number line going this way and this way. So our solution in interval notation would be negative infinity to positive infinity. And again, this is because no matter what value I plug in, it would either make this statement true or this statement. Okay, so we're using an either or. All right, second to last example. Here, going to be if we have x plus 4 is less than 0, or 6x is less than negative 12. So to solve this, I've got to isolate the x. So x is going to be less than negative 4. Don't need to flip the sign because I'm adding and subtracting. Here I need to divide by 6. Don't need to flip the sign because I'm dividing by a positive. All right, so this one says that x x right here is less than -4. So it's all of this stuff over here, but does not include -4 because there's no equal to here. And this one says that x is all stuff greater than -2, but does not include -2 because there's no equal to here. So this actually represents the full solution. You can see that only this area from -4 to 2 would make both statements false. Okay, so this is, both of them are false. So we cannot include this area, and this is where the union comes in. So this is approaching -infinity over here, and this is approaching +infinity. And again, that or means anything that would make either true, either one of them true. So I have from -infinity, which always has a parenthesis, to 4, -4, which has a parenthesis because there's no equal to. So this is a solution that makes this one true, all of these true. Or, this is where my union comes in, I'm talking about the values from -2, not including it, because there's no equal to sign here, to infinity, because infinity always has a union sign. Okay, so this would be our interval notation solution, and here would be our graph. So we don't include the values between -4 and -2. The last one I want to show you is a compound inequality that has some fractions in it. So we can see what to do with that. So, and it's going to be all together. So it says that -5 is less than or equal to a -3x plus 1 over 4, and it's also less than or equal to 2. So we treat these just like it's equal on both sides. So I'd say, well, this has a 4, and these are the same as being over 1. So I want to get rid of those, so I'm going to multiply by 4, both top and bottom. And I'm going to multiply here by 4, both top and bottom. So I can get rid of those fractions. So I'm going to get that -20 is less than or equal to a -3x plus 1, which is less than or equal to 8. Now, whatever I do to one side, I have to do to every side, and I only care what is connected to the variable. So again, I'm going to isolate this variable by subtracting 1. If I subtract it here, I have to subtract it here and here. So now I get that -21 is less than or equal to a -3x, which is less than or equal to 7. Okay, so now I'm going to divide by a -3. And remember, when you divide by a negative, you have to flip the sign. So I get that 7 is greater than or equal to x, which is greater than or equal to a -7/3. Okay, so what does this look like? Well, on my graph here, I've got -7/3 is like -2 1/3, but again, you'll never write it this way. So we've got 0, 1, 2, and a -2 1/3 here, which we will write as a -7/3. Okay, and then we've got our 7 over here. Okay, so this is saying and, because there is no and or, this is a compound inequality, then we're going to make sure that we keep it that way. So I'm looking for where 7 is greater than x. If 7 is greater than or equal to x, then we are talking about the value of 7 and everything less than that. Okay, but if x is also greater than a -7/3, x is greater than this -7/3, greater than or equal to, then it's going to include this. So if these keep going, again, we're going to look and say, well, where do they overlap? Because that, we're looking for this entire thing to be true. So what numbers could I substitute for x that would make both of these statements true? And in this case, it's everything between here and here. So our solution, or our graph, would be then a -7/3, 0, 7, and they're both included because there's equal to signs here. So we're looking at this being the graph, okay, with this in the middle. And the interval notation is a negative 7/3 including it, to 7 and including that. Okay, so that's the end of this video. Let me know if you have any questions, and we'll see you soon.